this with V1 equals, and you're going to solve that and get the correct answer for the problem. Number 8 is a different kind of problem. In that we're not making a dilution. What's our known and unknown? That's the best thing to look at first. The things we know is that we have 18.0 molar H2SO4, and we know something about that we want to get 2.45 grams of this H2SO4, but we don't know how many milliliters that volume is. Well, this turns out to be a good example of why it is helpful to keep track of your units, because the units here will help you solve this problem. So what we are going to do is just kind of play with our units a little bit. I'm going to write down the 2.45 grams of sodium of sulfuric acid, H2SO4. And then somehow I need to get grams to change into volume. Well, I know that I've got this relationship here between moles and volume, so maybe I'm going to switch this from grams to moles, and I can do that pretty easily. 1 mole of H2SO4 is how many grams of H2SO4. I can get out my calculator or get out my periodic table and calculate this. It's 98.09. That's the mass of 2 hydrogens, 1 sulfur, and 4 oxygens. And what that has done is made these units cancel. So in my puzzle, I'm trying to come out with milliliters, but I have a relationship between moles, so that if I have moles and liters, I have this relationship right up here with 18 moles per liter, right? So that means 18.0 moles of H2SO4 for every 1 liter of solution. And if I really want my answer to come out now in, those units canceled, and I want my answer to come out in milliliters, so I'm going to have to get liters to cancel, and my last unit up here is milliliters. 1 liter is 1,000 milliliters, and I calculate that, and I have my answer. To continue watching this review, go to Number 9, what mass in grams? So as I start this problem, I'm going to focus on realizing that the thing I am looking for is grams of potassium chloride that I need to solve this problem. And the things that I'm given to work with, the information I know, the thing I know is that I need to make 2.5 liters, and I need the solution to be 0.500 moles per liter. Because remember, the unit molarity is moles per liter. And once again, we're going to look at our units and what we need to do. Now, I know that I can get from moles to grams if I can just get rid of those liters. So as I set this problem up, That's the first thing I'm going to do is get rid of the liters. I'm just going to say, okay, 2.5 liters of this solution times how many moles per liter? 0.5 moles per liter. The liters cancel, and I now have moles of potassium chloride. Well, I know how to do the rest of the problem because I know how to change moles of potassium chloride to grams of potassium chloride. I have to get my moles of potassium chloride to cancel out, but that's pretty straightforward. So I just need to find the molar mass of potassium chloride. And some of you are probably way ahead of me with this. I'm pulling out my periodic table and I'm looking up potassium, which has a mass of 39.1, and chlorine, which is 35.45, and I come out with 74.55. Does that look right to everybody? That's the number of grams in 1 mole. So now I can calculate a number so that I can go on to answer my question. So 2.5 times 0.5 times 75.5. Did you guys get 94.38? Yes. I rounded it up just a little. 94.38 grams of potassium chloride. So to answer the I don't have to write a statement here, do I? But what I would be doing is I'd be mixing this into enough water to make 2.5 liters of solution. So in number 10, it does ask me to use a sentence. Are we ready to go to number 10? Okay, number 10. The thing I know in number 10 is that I have 1 liter. I'm going to make 1 liter of solution, and it's going to be 1.00 moles per liter. I'm getting that unit from right there. The thing I don't know, the thing I need to know is I have to mix this in grams. I have to be able to mass out a certain number of grams of sodium hydroxide pellets. So that's what I need so that I can describe how to mix this solution. So once again, it's going to be just like the problem we just finished. We're going to start with 1 liter of this solution, and we're going to multiply it by 1 mole per liter. That's the concentration. So this is, if you're wanting to make notes, some people memorize that this is volume times concentration equals moles, but other people just go, I'm going to use the units to cancel out and leave me with moles. Of course, from moles, we have to go to grams using our molar mass relationship. And sodium hydroxide is 40.00 grams per mole. I can do this without my calculator, can't I? Yeah. So that comes out to be 40.0 grams of sodium hydroxide. Now to answer the question, I am going to write add 40.00 grams of sodium hydroxide to how much water? Enough water to make how much solution? 1 liter of solution. And so that is the answer to question number 10. Number 11, what is the molarity of a solution prepared by dissolving, we're getting the easy ones now, aren't we? By dissolving 5.3 grams of sodium carbonate to make 40 milliliters of solution. So the thing we know here is that we're putting 5.30 grams of sodium carbonate into 400 milliliters of solution. And all we have to figure out is the molarity. Don't forget to write the formula for molarity. Have you guys already got this? You don't need me to go through this one? What's molarity equal? Mole of solute divided by liters of solution. Well, this is going to be easy. How do we get moles of solute? 5.30 grams of sodium carbonate, and we're going to convert that to moles. If you don't get the formula right, you're not going to get the molar mass right. So thanks for checking me on that. And so I've got to figure out the molar mass of sodium carbonate. So equals 0.0500 moles. Now remember, molarity equals 0.0500 moles of solute divided by, how many liters of solution are here? Are you guys getting 0.4 liters of solution? And so you should get 0.125 moles per liter, or 1.25 molar.